This video is a continuation of last video, but this time we want to find how high overhead will the projectile be when it is 5 kilometers downrange. And then we want to find what is the greatest height reached by the projectile. So, beginning with solving for C, we want to know how high overhead, which means we will be eventually using this equation for the y component. However, with the y component, we don't know what t is, therefore we can't solve for y yet. So we need to solve for t. But in this problem, it says over here that 5 kilometers is downrange, meaning that the x value is 5 kilometers. So we could plug in here and solve for t, and then after that, use t, plug t in here, and solve for y, okay? So to start, plug 5 kilometers for x. However, if you look, 5 kilometers and 600 meters, they are not the same unit. So you need to convert 5 kilometers into meters, and to do that, you multiply by 1,000. So you would have 5,000 equals velocity, initial velocity, which is 600 meters, times cosine angle, which is 60, times t. If you plug this into a calculator, you get 300. So divide by 300, 5,000 divided by 300, you get 50 over 3, which is 16.6, repeating. So it's around 16.6 repeating, around 16, let's say 6, 6, 7. Let's round it to 4 decimals. Okay, so this is t. Then you put t over here. So y equals 600 sine A, which is 60, times t, which is this number, 16.6667, minus 1/2 g, which is 9.8, times 16.6667 squared. Okay, plug that into a calculator. But before that, you want to know what sine 60 is. So sine 60 is square root of 3 over 2. So 600 times square root of 3 over 2, like this, times 16.6667 minus 1/2 g, which is 9.8, okay, multiplied by 16.6667, which is time squared. Now, answer you would get is 7,299 point and a whole lot of decimals. So this would be how high overhead in meters. So write that over there, 7,299 meters. This is your answer. Moving on to the next thing, let's make a note that time is 16.6. So I'm gonna erase this. T equals 16.6667. Okay. Now we want to know the greatest height reached by the projectile. And there's a formula for that to find the greatest height, and it's the y max formula, which I will be writing right here. Y max will equal to initial velocity times sine angle squared over 2g. Okay, so y max for us would be initial velocity, which is 600, sine angle, which is 60, squared over 2g, which is 9.8. And if you plug that into a calculator, you get 600 sine 60 squared over 2 times 9.8, 22.95. However, this would be a wrong way to do it, because the right way to do it would be to find sine 60 first. So sine 60 is root 3 over 2. So 600 multiplied by root 3 over 2 squared over 2 times 9.8. You get 13,775. So 3775. This is not a 5. 13775.5. So this would be your greatest height reached by the projectile. And if you want to round it, you would get 13,776. All right, so the answer for this is 13,776.